In this 7th installment of the Boeing 777 flight control series, we will understand how the leading-edge devices on the wings work. The aircraft has 14 slats, 12 outboard, and 2 inboard. Slats cannot be installed between the engine pylons and the inboard slats as their movement will be obstructed by the engine cowlings. Therefore, 2 Kruger flaps are installed to assist the slats. The slats are fly-by-wire controlled, with 3 modes of operation. The flap lever is used to select the 3 available slat positions: up, sealed, and gapped. Let's put the slats to the sealed position. When the flap lever is selected to 1, the position change signal is sent to the flap slat electronics unit. The computer first engages the primary mode for slat control. Then it sends a signal to the slat hydraulic valve. Center hydraulic system of the aircraft is used to operate the slats. The valve opens to run the hydraulic motor. The motor drives the slat power drive unit gearbox. Connected to the gearbox are the torque tubes. Angle gearboxes help route the torque tubes to the right wing. Now let's see how the torque tube rotation results in slat extension. Offset gearbox uses the torque tube rotation to drive a rotary actuator. The actuator rotates the slat pinion gear. There are 2 gear connections for each slat. The gears extend the slat to the sealed position with the help of tracks. The Kruger flap has 2 positions, retracted or fully extended, and instead of gears and tracks, uses a pushrod connection. Just like the inboard slats, the outboard slats extend with the help of gears and tracks. Position sensors on the offset gearbox measures the torque tube rotation and sends the signal to the flap slat computer. This allows the computer to determine the slat position and control them with precision. Flap lever position 5, 15, and 20 controls the trailing edge flaps. The slats remain in the sealed position. Changing the lever position from 20 to 25 results in both the flap and slat movement, but they will not extend simultaneously. The computer will follow a sequence. First, it will command the slat power drive unit and move the slats to the gapped position. After slats extend, the flaps are moved to 25. Flaps 30 will move the trailing edge flap to its maximum extension. Now let's look at the retraction sequence. First, the flaps retract to 20. Next, the slats are commanded to the sealed position. If the hydraulic components fail during a slat command, the computer will automatically switch to the secondary mode. In secondary mode, signal is sent to the electric motor to operate the power drive unit. The torque tubes are driven in the opposite direction, and the slats retract to the sealed position. Next step in the sequence, the computer retracts the flaps up. Finally, the slats are moved to the retracted position. If the computer malfunctions, the flaps and slats can be controlled using the alternate mode. Arming the system will disengage the current mode and prevent the computer from controlling the flaps and slats. Let's extend the slats in alternate mode. The switch directly sends a signal to the electric motor to run. Since the computer has been bypassed, there will be no sequencing. The slats and flaps will extend simultaneously. In the alternate mode, the slats can only be extended to the sealed position, and flaps to maximum 20. As we have covered all the flight control surfaces, in our next part of the series, we will understand their function in flight. Thanks for watching.